After introducing some design models in applications, we took one library interface known as special iterator, or you can say split iterator. This Java 8 new version anyway. Yesterday I took a diagrammatic. So let me show that once for 5 minutes. And if any doubt is there, I'll recollect at once. Right. So you can see yesterday's analysis, what we done. This is java.util.special iterator. Whenever you want to create object for this implementation object indirectly, we are having one method known as special iterator from arrays class. Internal to this method, one implementation object created. The reference will be available on OB. That's the information. Using that OB, you have to call for each remaining method. But whenever you are calling for each remaining method, we must pass this lambda expression as parameter. Whenever we pass lambda expression as parameter, we need one functional interface. So consumer is the functional interface. For each remaining method, having consumer as parameter. Because of this, so analyze this once and you work once. For today's class, after giving information about lambda expressions and some assignment solutions, design models, introducing one, right? Let us go for one more. Star mark IMP method references in Java. This also Java 8 new feature. This also Java 8 new feature. Method references in Java. Method references in Java. Right. So I'll take always one repeated interface here. I test always. Having one method here, abstract method, void m of int k I'm taking. So one interface declared with one abstract method. Right. I'm having one class here. one class here. This is one class. The class is display. I had one class known as display. One class. This display class is having one constructor, display of int x. One constructor, this is. One constructor. One constructor. Having one instance method here, void display one of int y. One instance method available here. Instance method available. One instance method. One static method available here. One static method. Void display 2 of int z. One static method. One static method. One constructor, one static method, one instance method. Okay, right. This interface and class, there is no relation between these two components. Relation not there. Relation means maybe references, maybe inheritance, maybe inner class. There's only three relations, only three types. Okay, right. So there is no relation between these two components. Simply I'll comment no relation here. No relation means the two components are independent. That's the meaning. The two components are independent. But here concept is nothing but whenever you want to write one lambda expression here, how will write the lambda? Sir, I test to OB equal to int k and lambda. Yes or no? Na? Because we are leaving lambda over discussion. With method reference, we are leaving lambda and going for the next unit. Exception handling is coming. Next coming unit. Okay, right. We are leaving. This is lambda. So here the concept what you learned up to now is, sir, one interface is there means I can write one body in the form of lambda expression. I can write it. Understood this? Right. But it says that interface says that not like this. I don't want you to write the body. I want body of constructor. Nothing but here through this. I want the body of constructor. I want the body of instance method. I want the body of static method. So I want the body of method which belongs to another class. You don't write the body like this. That is the next concept. Lambda expression. We are writing the body we are writing the method body in the form of expression. That concept over. In the Java 8 only they given one more feature. One more feature is nothing but no need to write the body in the form of expression. Already any class is there means from that class you take the body. That concept we call it as a method reference. The process in which abstract method of functional interface is attached with the body, attached with the method body of a class, where the class is not related to interface is known as a method reference. The class not related to interface, but we are taking the body. That concept we call it as a method reference concept. Many people don't know this feature. 80% of people available in the market, still they are not educated this feature. Generally providing the body without a name only, many people are not understanding. Now you are taking the body from another class means we will understand. There's a new feature available to you. The process in which abstract method of functional interface is attached with the method body from a class where the class is not related to interface is known as method reference concept. Write it. It's a new concept. The process in which abstract method of abstract method of functional interface. The process in which abstract method of functional interface is attached with the method body from a class. The process in which abstract method of functional interface is attached with the method body from a class where the class is not related to functional interface, is known as method reference concept. The process in which abstract method of functional interface is attached with the method body from a class where the class is not related to functional interface is known as method reference concept. These method references are categorized into three types. These method references are categorized into three types. Reference to constructor, reference to instance method, reference to static method. Reference to instance method, reference to static method. So three types will be there. Right. First, let me construct the components in your program and I'll explain them one by one. Observe it. Right. See there. Right. I am taking one application. That application name is method references application. Method. I forget it. Anybody lost your gold ring? Right? So they asked me to announce it generally. That is with the supervisor. Any of your friends missed any gold ring? Contact supervisor. That gold ring is available with them. Any of your friends discussion goes, you say it. Okay, right. Forget it. Right. Look here. Now look here. I'll forget it because I said I remembered. Okay, right. Now look here. Method references here. Package test. Maxes. Right. Now here I'm taking one interface. I test. I'll take one class that is display. Display. I'll take one class. Under I test, I'll take one method, public, abstract, void m of int k. I'll take one class where one constructor display of int x, one instance method void display one of int y, one static method public static void display 2 of int z, like this. Now this body is constructor body system dot out dot println. So this is constructor body. Some message. Now system dot out dot println. The value x is equal to plus x. Instance method body y and y. This is static method body. Method body. Like this. One is constructor, one is instance method, one is static method. All of it clear? Right. Okay. Now look here. Now these two are two different components. Okay, right. Now I want reference to constructor. Make it reference to constructor. The process in which abstract method of functional interface is attached with the constructor body. The process in which the abstract method of functional interface is attached with the constructor body is known as reference to constructor. You can say reference to constructor. You can say reference to constructor. You can say. Reference to constructor, you can say. Now, sir, how you'll write the syntax here? See there, syntax. You don't write it. I'll be writing. See there. General syntax is syntax and example. Anyway, here you have to take functional interface name. Functional interface name obj equal to. Here functional interface name is iTest. OB1 is equal to. Now, whenever you want to write the lambda, you'll write lambda directly. But I want the body of constructor. Already you know the constructor chapter. Constructor is a special method having the same name of the class and executed while object creation, because the constructor call is available in object creation syntax attached with new keyword. There's a definition I written. So new keyword is there means constructor call is there. So new keyword is there means constructor. So new means constructor. Whenever I say equal to new means new refers the constructor. New keyword refers the constructor name. But constructor available from where means scope. Scope means where it is available. That's the meaning. So this is the scope operator. So it says scope, where it is available. Where it is available means I must say the class name. I must say the class name. In which class the constructor is there. That's called scope. So constructor scope is within the class. So here what is the class name here? Sir, class name is display scope new. That's the syntax. So what happened now? The body of constructor will come and add to the method of interface. Right? That syntax. It's a new syntax. There also object created. iTest OB1 is equal to display scope new. Right. Sir, what happened here? I want to know, sir. See, in this syntax, what happened means is either diagrammatic. Suppose if I use this syntax, if I use this syntax, if I use this syntax, here also object created. Here also object created. So in this object, here also one object created. In this object, this method will come. Void m of int k. Lambda expression rule, that only know. The method should come from here. From the interface, the method should come. And body will come from here. Constructor body will come from here. That only concept. How the constructor body is coming? You said new, no? New. New refers constructor. Constructor is within the scope of display. In display, constructor body is taken. When the constructor body is taken here int x will come, followed by body. This is constructor body. The constructor body is attached. That constructor body is attached. So whenever I say OB1 dot, if I say OB1 dot M of 121, constructor body answer will come. Because M is attached with the body of constructor now. Already you know. Lambda expression is executed with the name of abstract method you are executing now. Yesterday also accept method only no indirectly. So if I call M, automatically constructor body should run. Whether it is running or not, let me cross check. I'll go to main class here. I'll go to main class, demo method references, demo method references, import, import test dot star, import it here. I am taking I test OB1 is equal to display scope new. This one we are calling it as reference to constructor, you are saying. Reference to constructor, you are saying. Now call it OB1.M 121. So here constructor body executed. If you run it, constructor body will come. Constructor body is coming or not now? That is a proof to say that constructor body added to the abstract method of one interface. But here, display class nowhere related to interface. This concept we call it as method reference. Now this reference in this diagram, 0x11 is the reference to constructor. Reference to constructor means in this reference, constructor body is available. All have understood this? Yes or no? Right. Now comes the similar reference to instance method. Make it reference to instance method. The process in which abstract method of functional interface is attached with the instance method body. Instance method body is known as reference to instance method. Reference to instance method. The process in which abstract method of functional interface is attached with the instance body. Instance method body is known as reference to instance method. Right. Now instance method will get the memory within the class or within the object. Within the object. You have to create object first. You have to create object first. So whenever I want to take the instance method, I must create object for display. If I create object for display, instance method will get the memory. Then I can take the body. See there. Now in this program now, I am creating object for display. Display D is equal to new display. I am writing 100. Now this also constructor call, you know, yes or no? This also constructor call. So constructor executed 2 times now. This is for M method. This is for normal constructor. Okay, right? Sir, here one object is created. one object is created. One object is created. One object created. In this object, the display method will get the memory. Void display one of int x. So this display method, memory will come here first. This you understood now? Right. Now from that object, you have to take the body. See how it takes now, syntax. Here, the syntax is functional interface. See there. I want the body. So in functional interface says that I want the body of method. Which method now? Say the instance method name, you say. Instance method name, you say. So instance method name means display one, no? Yes or no? Right. Now the method available within the class or within the object? Within the object. Say the object name. Say the object name. In the place of display, you must write what now? T. Means this method scope within the object. That's the meaning. So I want the body of display one. This is syntax. So I am taking the body of display one. Write it. Right. See there. For this, I'll draw the diagram. Now, in the diagrammatic here, in the diagrammatic, just imaginary diagram. This is the syntax. For this syntax, 0x33. Here one object created. For this object, the method will come. Void m of int k. First, the method will come here. From functional interface, the method will come. Then the body will come from here. From here, the body will come. From the object, the body should come. Y means here you said D, no? Right. D means address location, no? From that address location, the body will come. Int x. X or Y? Y, no? Y. Here body. Here instance method body. Like this. Now, whenever you want to run this now, you can run OB1. OB1 or 2? Here I not written. This is 2. Yes or no? Right. OB2. OB2 dot M of 122. This is 2 actually. I have to change the name now. Right. All of you understood this? Right. So abstract method attached with the body of instance method. It's a new concept. Now see there, I'm applying here. Here, I test OB2 is equal to D scope display 1. It's a syntax. Now, reference to constructor. Reference to constructor. Sorry. Reference to instance method. To instance method. OB2.M122. This is instance method body executed. The body will come out. All of understood this? It's a new syntax. Now go with the last one. Last one means reference to static method. The process in which abstract method of functional interface is attached with the static method body. Static method body is known as reference to static method. Static method available in the class, available in the object class. You can refer by the class directly. Refer by the class directly. Here instead of object name, you must say class name because the method available in the class. So static method name. Here OB3, you can write a class name as display. Here display 2. The syntax. Right. See there, I'm drawing the diagram first. Diagram. Here one address will come anyway. 0x44. Here object created. First the method should come from interface. Void m of int k. The body ought to take from the class, scope class. So the body taken from the class. Here, int chat body. This is static method body. Whenever I want to call this body, I had OB3.M of 123 like this. Now the same thing I will write it here. I test OB3 is equal to class name display scope display 2. Now this is reference to static method. I'll call OB3.M 123. This is static method body executed. The answer will come out. All of you understood the syntaxes, right? It's a new concept. Whenever you know lambda expression, you must practice method reference also. Wherever the situation comes, you have to decode it. Okay, right? So this is the diagram where we had 3 method references like this. This reference to constructor, first one. Second one is reference to instance method, means body is available. Here, reference to static method. Here, objects are created with lambda expressions. Objects are created with method references. This is a new pattern. Like old pattern, new operator is not mandatory here. Class name, object name is equal to new class. That is an old pattern. So that also object is created, but new things has been changed. Algorithms will be changing, no? So when the researches is going on, algorithm will be changing and coming. So without new operator also objects will come. They are coming already. So this is the diagram. All of you understood this model, right? Sir, where I can see this model? Already I shown that local inner class already there. Like iterative statements, many things are going to see. I shown one example for local inner class, anonymous local inner class. Already inner classes available in the protection and security. That member inner classes, you had protection and security is there. This one available in the threading. This one is very popular in the web services. In the web service, you can, wherever you find scope operator, immediately take that code, go home, come home, nothing but come home, open my book and see the model. Understood now? You'll get the clarity. Whether scope before they used a class name, object name, if not new operator, my model will be there in my book. So that you can trace out and apply it. That work you have to do. Very 10% of students only will do that work. Remaining all directly again. Directly means what? Core Java completed, forget it. Again, they'll start advanced Java, forget it. They'll start Spring, forget it. They'll start web service, forget it. They'll go to company. Right? Means what? They will not apply. They will not carry. But you have to carry them. One by one, you have to carry forward and go. When you are carrying forward, this model is available to you. Method references. Method references available. So example here. Example program. itest.java demo method references dot java. This is one main class and this is one output, followed by the diagram available to you. It's a concept. The diagram I'll paste there. All of you understood this? Right. Okay. Now see there. Whenever somebody asked, do you know Java 8 features means? Answer is yes only. Anyway. So what are the features you know? Somebody asked. First, you must say lambda expression. Second one, method reference. Right? Third one, concrete methods in interfaces. That is the order. First one is what now? Lambda. Whenever you say lambda, it gives a positive mark to you. You know lambda. Right? Second one, method reference, more positive mark. because method reference available in the web service. In your advanced Java, you never see inner class. You never see inner class. When you cross advanced Java, you are going to see this chapter. This chapter is a level 3 chapter. Level 2 is advanced. Level 1 is core. Level 3 is framework. In that framework, Spring and web service will be there. This chapter belongs to level 3. The chapter not belongs to level 2. This all chapter belongs to level 3 only. So these models you are going to see there. So all models are available in the market to you. Whenever somebody asks 8 features, you must say lambda expression, method references, then concrete methods in interface. These 3 you have to highlight it. These 3 only popular in the market. Understood this? Right. Okay. Now, we are under which unit now? Sir, we are under inner classes. Yes, sir, no, na. Right. Inner class. The process of declaring the class inside the class is known as inner class. There only we started the concept now. Sir, this is one class, sir. This is one interface, sir. This is one abstract class, sir. In class, variables came, concrete methods came, blocks came, constructors came, features came, at last inner classes came in the form of static, non-static. This non-static in the form of outside the method, inside the method. Instance and local. This local inner classes became anonymous. Without name, no? Right. That anonymous became lambda expression. So you know anonymous inner class, you know member inner class, you know lambda expression, you know method references today. Yes, sir, no, na. Right. Now, when the inner class available within the class, what about the interface? Interface, sir, variables are there, concrete method scheme, concrete methods, sir, abstract methods, of course, blocks and constructors not available. So blocks and constructors not available. Now features came. Right. Now inner classes also possible. You can write inner classes also possible. These inner classes will be static. Only static inner classes will be there. What about abstract class, sir? Abstract class, variables possible, concrete methods, abstract methods, blocks possible, constructors possible, and features. Sir, inner classes possible means when it is possible in the class, it also possible here. So inner classes. Sir, inner classes available here. When the class is having static, non-static, Here also possible. Static and non-static. All of understood this analysis? Right. Now, when our inner class is coming now, write the two programs now. Inner class inside the interface. Inner class inside the abstract class. Let us write it. Make a siding. We are coming for conclusions. Inner classes in interfaces. Inner classes and interfaces. We can also declare inner classes in interfaces, and which can be inner classes. We can also declare inner classes in interfaces, and which are automatically static member inner classes. Static member inner classes. They are automatically static member inner classes. Right. See there. Star mark IMP inner classes in abstract classes. We can also declare inner classes in abstract classes. We can also declare inner classes in abstract classes, and which can be static member inner classes or non-static member inner classes. Non-static member inner classes. We can also declare inner classes in abstract classes, and which can be static member inner classes or non-static. Anything you can declare. Both are allowed. You can declare anyone. Right. So example, let me test it. Example, let me test that. Can I write inner class inside the interface or not? Let me test it. Now look here. I am taking inner classes application 4. I am taking. Inner classes application 4 I am taking. New package test. Maxes. Right. Under this test, I am taking one interface, I test. This is outer interface. Inside this, I am writing one class. I am writing that class is automatically static. I am writing static class subclass 2. I am writing this is one static member inner class. Now inside this, I'll write one method void m2 of some int x. I'll write it. From this body, I am printing some m2. I'll print it. m2 of x. I'm printing. Now system dot out dot print ln. The value x is equal to plus x. Now anyway, one class is inside. You know static member inner classes, no? Yes or no? Na? From today, all yes only. Because next chapter is exception handle. It takes maximum 3 sessions. Polymorphism means conclusion of features. It takes 2 sessions. Biggest chapters not available, all small only. After polymorphism, collection will be started. That only biggest chapter. Collection. Data structures in Java. That chapter take much time. Biggest when compared to all these. After collection, there only map will come, enum will come. That all together collection. After that third chapter collection, multi-thread, 2 sessions, the concept, multi-thread. After that, 1 session file, 1 session network. Course will be ended. So remaining all chapters are applicative chapters. Means if you are strong up to now, you can apply it. So inner classes completed means you can take one long breath. Without your knowledge, one day course is going to be ended. Already we are late because of Dasara. Yes or no? 10 days before Dasara, Venkatesh sir typed very slowly. I wasted time or not now? So almost 10 days we are delayed. If not, your batch might have ended already. So anyway, we are coming means inner class is the last model. That's the concept. So from today, all yes only, no, not there. Why means I learned everything, sir. I can remember, sir. Static member inner class. What is object creation syntax? Outer class name dot inner class ob equal to new outer class dot new outer class dot inner class. That is the object creation syntax. No. Here static member inner class inside the interface. No. Here outer class replaced with the interface. Interface dot inner class ob is equal to new interface dot inner class. We can create object very easily or not now. See there. I am going for main class. Demo inner classes for import test dot star. Now here I have to create object now. So system dot out dot print ln. I am putting one comment output purpose. The answer is coming from inner class within interface. Inner class in interface. The answer is coming. For this, what is object creation now? I test dot subclass 2 ob2 is equal to new I test dot subclass 2. You can call ob2 dot m2. The answer is coming no. So inner class inside the interface is possible. If anybody asks in the interview, say it. Inner class inside the interface application not there. Up to now, the models are applicative models. This is one concept less used. If anybody asked in the interview, you are writing one class inside the class, no? Can you write one class inside the interface? They'll ask it. Answer is yes. Instead of making a statement, I'm writing a program. It is possible. I'm showing. Got it right. Now, what is the second model now? Second model is inner classes in abstract classes. That can be two types, no? Right. Now I am taking one abstract class. I am taking right click on test now. New one class, that is abstract class, a class abstract. Now this is outer abstract class. Now here I am taking one class, public class subclass 3. I will take it. This is instance member inner class. I'll take public static class subclass 3. I can take static member inner class. Static member inner class. Here I'll take public void M3 of int P. I'm taking roughly here. So public void M33 of int Q. I will take it. This time taking one is instance member inner class, one is static member inner class. Now system dot out dot print ln. I am printing from M3 of P. I am printing. Now system dot out dot print ln the value P is equal to plus P. Sir, this is from M33. This is Q. This is Q and this is Q. You know how to create object for instance member inner class. What is the syntax now? Outer class dot inner class OB is equal to outer class object name dot new inner class. These two models only important actually, because I asked you to highlight it, the two models, and the two diagrams only I drawn actually. Remaining all I am coming, because total depends upon the two only. Because the two more diagrams I kept it. I asked you to take the printout also. If you are not taking printout also, one day you will take it. One day will come. On that day you will search my book. Don't throw it, keep it. My book will play a role. Because order is there in my book. Subject order is there. One day you will refer it. Definitely. On that day you will remember me also. Venkatesh sir said, unnecessarily not it took means because I am a pillar for your career. I am a pillar. One of the pillar for you. Your school age trains teachers are there. Many teachers are there. Among that, my name also will be there because career pillar I am. Because the language, grammar you are learning from me. The many models you are learning from me. So I only will play a role to you. Remaining all, they will use my models. They'll use my models. Because I'm introducing this concept. That because I written that syntax. I asked you to write in the box also. I drawn the diagram. One session I given for each diagram. You observed already. Now here, very important. Sir, outer class object dot new inner class. Here outer class object is abstract class, no? Here outer class object is abstract class or not now? Abstract class object not there, no? Implemented objects are there, direct object not there. Let us see what happens. See there. Sir, I want outer class object. If I want to create here, system dot out dot print ln, I am writing star inner class in abstract class. Inner class in abstract class I am writing. Now I want to create object for instance member inner class. So outer class object I must create it now. Outer class means abstract class. Abstract class OB equal to new abstract class. Error will come now, sir. And moreover, lambda expression is for interfaces only. Yes or no? Na? I written that statement also. When lambda expression is coming, I'll write bit carefully only. Generally, if I forget, I cannot say. But when the concept is coming, I'll remember it and write it. Generally, I written that statement also when the lambda is coming. See there. Anonymous inner class as implementation class model is modified as lambda expression. In the document also available. Already I am certified in 8 already. Already certified. I written examination, I passed already. So when I am reading, I read that document very clearly. I read it. So they said very clearly, educate your student very clearly. Wherever the anonymous model is there, wherever the choice to replace that anonymous, ask him to replace with lambda. If more methods are there, ask him to move that methods as a concrete methods to interface so that you can save the time. That only concrete method concept. That is actual document. Actually, anonymous inner class means more number of methods are there. Suppose I cannot write lambda expression. You take any one important method and take lambda. Remaining all you convert into concrete. You move the bodies to interface. That only flexibility. So that what happened, dot class files will be decreased. So that high performance will, that only concept. Because I written very clearly here, anonymous inner class has implementation class model is modified as lambda, I said. Means what? Another model is there, no? Anonymous inner class has class extension model not modified to lambda. Means what? Lambda is for interfaces only. Understood this point? Lambda is for interfaces only. When the lambda is for interfaces, abstract class lambda not there. Sir, how to create object means create anonymous. Anonymous is there no for you. You can write one anonymous body, no? Yes or no, na? This is anonymous body only. This body is anonymous. Sir, this is anonymous inner class with 0 members. Not there. I written one empty body or not now? But object is created, no? Yes or no, na? Object created. Because I written with 0 members or not now? Body I given. So object came now already. When the object comes, use it. How will you use it now? Sir, abstract class dot subclass 3 OB3 is equal to outer class object name is OB, no? OB dot new subclass 3. Object came out, no? That is the syntax. So OB dot M3, sorry, OB3 dot M3, you run it. Anyway, if you want to create for static member in our class, issue not there. Abstract class dot subclass 33 OB33 equal to new abstract class dot here subclass 33. For static member inner class, issue not there. For non-static member inner class only, outer class object needed. But outer class is an abstract class. Abstract class you create object with anonymous implementation. All of you can remember this model, right? OB33 dot M33 and answer. So answer will come. Inner class in interface possible. Inner class in abstract class possible. All have understood this concept, right? Okay, these two are possible. I took eye test dot Java, abstract class dot Java. Here demo inner classes 4 dot Java. This is one main class. So finally, you can declare inner classes, in classes, inner classes, in interfaces, inner classes, in abstract classes. All of you understood this, right? Okay. Sir, when inner class is there, what about inner interfaces? If inner class is there, what about inner interfaces? Yes, inner interfaces also available. In your library, they are already sitting here. In your library, Java P, Java dot util dot map. This is map is one interface. This is one interface or not now, right? Clear it, right? Map dot entry. Can you see dollar symbol? Dollar symbol means inner, no, right? Entry is a inner interface. Means what? Interface holding one more interface, no? Understood now? So inner interfaces also available. Make a siding. Inner interfaces in Java. Star mark IMP. Inner interfaces in Java. All are attending Advanced Java? How many of you are attending? Raise your hands. Very good. Now, see there. Inner interfaces here. I am bringing inner interfaces. Whatever I bring the inner interfaces, this is static and non-static. Static and non-static. Here, inner interfaces automatically static. Automatically static. Here also, inner interfaces static and non-static. Static and non-static. The same way, inner abstract classes also will come. Inner abstract class also available. Static and non-static. Inner abstract classes. Static. Inner abstract classes. Static and non-static. Can I write inner interfaces tomorrow? Right. Right. It takes 15 minutes anyway. Tomorrow, inner interfaces, inner abstract class, inner interfaces, I'll write program. Inner abstract class theory and assignment, that is. After that, conclusion of your programming components, total conclusion. Then tomorrow you will get the introduction to exception handle. Next chapter will be started. Right? Okay. Take a break. So thank you very much for today.
We attended advanced Java. You didn't discuss the anonymous object creation.
ఫస్ట్ స్టూడెంట్స్ వాళ్ళు పంపించుకో వాళ్ళందరూ ఇంకో వాళ్ళు అలా చేయరు సార్. అలాంటి వాళ్ళు వచ్చి పోతుంటే వాళ్ళు వరస్ట్ వాళ్ళు ఇంకోసారి ఎలా చేయొద్దు. నేను అందుకే ఊరికెళ్ళాను. ఆయన అంటే పిలిచినారు సార్ మాకు, అదొక రింగ్ టోన్ ఆయన.